Hello, and welcome to this short video showing some of our capabilities at Brooks Bell. My name is Kieran Dodworth, I'm Director of Naval Architecture, and I'm going to be your guide for this show. One of the most advanced tools that we can bring to bear on challenging cases and projects is CFD, that's computational fluid dynamics. This is a fundamental solution of fluid flow problems and is used in industries as diverse as Formula One car racing to the designers of heart valves. At Brooks Bell, we use CFD, amongst other things, for solving the flow around ship hulls. We have been in the CFD field for almost 20 years as one of the first companies to take up this fantastic tool. This slide shows the wave pattern around a super yacht hull form. CFD can also be used for propellers, like in this study, which was investigating an energy-saving device for our client. You can see here the pressure on the ship hull and the propeller blades. This slide shows one of our earliest projects in CFD, which was to investigate the fatigue of a rudder on a large container ship in 2002. The vessel was having major problems with a recurring crack appearing after around a year of successive repairs. We used CFD to solve the pressures over the rudder as the first step to investigate the cause of the recurring crack. In this slide, you can see the finite element model we constructed showing the area of high stress corresponding to the area of fatigue. We suggested here the cutting away of some of the steel plate and the removal of the Costa bulb. As a result of our intervention, no further occurrence of crack has been reported after nearly 2 decades. Here we show an analysis of a lifeboat being launched from a RoPax vessel. This involves the coupled solution of the ship in waves and the lifeboat launch. Brooks Bell is at the forefront of development of lifeboats and life-saving appliances. We were part of the project team that first applied alternative design for large lifeboats on post-Panamax cruise ships, like Royal Caribbean's Oasis of the Seas. This slide shows the analysis of a container ship fully laden. Our client was interested in the possible advantage of using roll stabilization, so the analysis includes the incorporation of stabilizer fins in the design. In Brooks Bell, we handle a lot of container stow collapses, and this slide gives us an idea of some of our capabilities in that field. Here we show a finite element model of a container stack, which is an approach we've adopted for large claims for around 15 years. During that time, we were alone in advocating the use of finite element analysis for container stacks, but recently the idea has been adopted by DNVGL in their latest StowLash software. This slide shows an analysis of an anchor handling tug and supply vessel during an anchor handling operation. You can see the vessel heel to starboard due to the chain loads applied. This slide shows the flooding of a cargo vessel using our in-house flooding software. The internal water, which is shown in turquoise in these plots, causes an initial heel, but a cargo shift exacerbates the healing effect of the water and results in a capsize. In this slide, we show a CFD analysis of a gate valve, which has been used to calculate pressure losses in pipes and the speed of water throughout a vessel's piping system. In this slide, we show streamlines of wind over a ro-ro ferry superstructure. In this particular case, we were looking at the flow into the car deck ventilation system and how it might have affected a fire. We've been using CFD for superstructure analysis for around 15 years. And we were responsible for groundbreaking work in the development of passenger comfort in highly novel cruise ships. The practice has become widespread now in the industry, but we still provide advice and analysis on many new building projects. We also apply CFD in the case of cargo vessels which have had major changes to their exhaust systems, as is happening more and more with the rollout of scrubber technology. This slide shows the plumes from a container vessel. The same type of analysis can be applied to confirm compliance with helicopter safety studies, such as in this case. This shows a contour map of wind conditions at various levels above the helideck. Some more complex CFD is shown in this slide, which shows a bow thruster in working mode. The animation shows the streamlines, but it can also be used to calculate pressures over the hull and the propeller blades and forces of various components. This video shows a roll stabilization fin working at anchor. This system is used increasingly on superyachts to minimize roll. We have extensive experience in this area, working both in their development and investigations of failures. Here we show the use of CFD to quantify bank effect, the forces and moments applied to a ship as it nears a bank of a restricted waterway. If anyone would like to know more, don't miss Dr. Nick Doherty's webinar on the topic on Thursday. Places are still available, so just contact us on our website. Here we show an analysis of water movement inside tanks, also known as sloshing. Fluids in tanks are always in motion, but it can become quite violent when the frequency of the ship motion coincides with the natural frequencies of the tank's motion. It is possible for fluid to damage tank structure when this occurs. Interestingly, some of the earliest work on sloshing appears in papers by NASA, who are interested in the motion of rocket fuel in tanks. This slide shows a RAN CFD analysis of a container ship in head seas. The most widely used form of CFD for ship motions is known as potential theory CFD. That's our primary tool for ship motion, but RAN CFD such as this has its uses on more complex cases such as water on deck. CFD can also be used to simulate fires, as seen in this slide. It is possible to model the progress of smoke, heat, and noxious gases in more complex analysis, the combustion process itself. These slides shows a simple design fire where the fire source has a fixed rate of heat input. We have used these models in many design studies, but they've also been applied in investigations of fire incidents. This video shows another design fire, this time in a cabin suite. This picture shows some of our finite element capability. This is a bulk carrier bulkhead, which is colored according to the material stress. Most of the work we do is on fully nonlinear FEA, which allows the collapse of a structural component to be modeled. This is because, in investigations, we're normally interested in the load required to break, fracture, or collapse a structure. We do perform some linear finite element analysis when addressing aspects of rule compliance or fatigue. This slide shows a similar analysis of the web frame of an ore carrier. This slide shows the modeling of a collision using finite element analysis. We can see an example of a ship bow first indenting and then rupturing the side shell of a struck ship. This video highlights some of the work we do in the area of fishing safety and fishing vessel investigations. Although this is made using rendering software, the shape of the wave and the motion of the fishing vessel is faithful to the underlying mathematics of the analysis. Fishing vessels can present a serious problem in analysis, as they are smaller vessels, often in the presence of large waves. The standard seakeeping analysis software cannot accurately model their motion, which is why we rely on more advanced analyses for small vessels. These videos show the example of a fishing vessel with a snagged trawl. The video on the left shows an analysis using our in-house seakeeping software, and then the one on the right shows the comparable experiment. These experiments were actually performed in the Denny tank in Dumbarton, which was the second tank ever constructed, the first being William Froude's in Torquay. This slide is an example of the use of CFD to calculate the loads on subsea pipes. In this slide, we show the use of Orcaflex to model the mooring of a shuttle tanker to an FPSO in the presence of waves. Orcaflex can perform complex chain, mooring and riser analyses for complex cases. For simpler cases, we rely on BB-Sim software or the Optimore software produced by Tension Technologies UK. In this video, you can see our ship handling simulation software BB-Sim simulate the docking of a container vessel at Tyneside. The video shows a 3D bird's eye view of the docking, but views from the bridge or the quay are also possible. Our ship handling software uses state-of-the-art science available in peer-reviewed papers. It is written and maintained by experts in Brooks Bell, so that we can stand by our models in reports and hearings. The application of CFD in complex cases means we have the strongest possible capability in the simulation of groundings and collisions. You can read more in our October newsletter, which highlights this capability. In some cases, it is necessary to understand what the view from the bridge was as an incident unfolds. In those cases, we can perform 3D animations to assist tribunals and courts to understand how an incident unfolded. Other applications can be the workings of complex machinery or the layout of an engine room when it has a particular importance to an investigation. We show in this slide our services in Cofferdam design and installation supervision. We've performed Cofferdam designs and supervised their installation for a wide range of vessels. It's not just vessels that we've designed cofferdams for. In this slide, we show our design of a cofferdam for a new quay wall for a port in British Columbia, Canada. We do thank you for watching this presentation of some of our services. We hope it was informative and interesting for you. If you would like to know more, please come and talk to us during the conference or on another occasion. Have a great conference and keep safe.